Hello everyone. In this lesson, we will investigate the definite integral. We will be making a connection between the definite integral as an idea that it is the limit as n approaches infinity of the rectangular areas that we looked at in the previous lesson, or what we call Riemann sums. Let's look at a couple of examples. For this problem, consider the function f of x is equal to 4x minus 5 on the interval 0, 2. Determine the Riemann sum for f on 0, 2 using n subintervals of equal width and choosing the evaluation points to be the right endpoints. Your final answer can only include numbers, trig and/or log functions, arithmetic operations, and the variable n. If we let the endpoints of the interval be a, b, the closed interval a, b, then a is equal to 0, b is equal to 2, delta x will be equal to 2 minus 0 over n, which is equal to 2 over n. The c sub k's will be equal to a plus delta x times k, should be equal to 0 plus 2 over n times k, which is equal to 2k over n. Your height of your rectangles would be f of c sub k should be equal to 4 times 2k over n minus 5 equals 8k over n minus 5. For s sub n, or Riemann sums, as we call them, be equal to summation k equals 1 through n of a 8k over n minus 5 times 2 over n, which is equal to summation k equals 1 to n of 16k over n squared minus 10 over n. That is by distributing this 2 through the numerator, 2 times n, 2 over n. And if we expand this and use our rules or properties of summation, we will have 16 over n squared by using the scalar multiple idea, pulling out the 16n squared to the left of the summation sign, and then by using the formula for summation summation k equals 1 to n of k, which was n times n plus 1 over 2. We have 16 over n squared times n plus 1 over 2 minus 10n, so that's 10n. If you pulled the 10n through to the left of the summation sign, you'll have 10 over n times the summation of k equals 1 to n of 1, and then that would just be n. So then, simplify our answer a little bit, it becomes 8 times n plus 1 over n minus 10. Use your work from the previous part to determine the integral of f on the interval 0, 2. In this case, we take the limit as n approaches infinity of s sub n be equal to the limit as n approaches infinity of 8n plus 8 all over n minus 10, which is equal to the limit as n approaches infinity of 8 plus 8 over n minus 10. So that would be equal to 8 minus 10, because this 8 over n here approaches 0 as n approaches infinity. So that would be 8 minus 10, and that would be equal to -2. So -2 is our area right here, and then our -2 will be equal to your integral 0 to 2 of 4x minus 5 dx. Okay, so -2, your answer here is your definite integral. Part C and D. Part C, determine the net area between the graph of f and the x-axis on 0, 2. And D, determine the total area between the graph of f and the x-axis on 0, 2. A hint here that you might want to sketch the graph. Our net area is our definite integral, and that's the integral 0 to 2, which we calculated, of 4x minus 5 dx is equal to -2. The total area equal to the area of one triangle plus the area of the other triangle. That's 1/2, 5, that's 5/4, plus 1/2, 3 times 3/4, that's going to be equal to 25/8 plus 9/8 equals 34/8. And so for a sketch of these triangles, you can look at the points. Our x-intercept is at 5/4, so this distance here can consider that as the base of the triangle is 5/4, and then the height is 5, so that's how you get the 1/2 of 5 times 5/4. And then for this green triangle, the base is 3/4, and the height would be 3. Okay, because this point, the point right here is 2, 3, 2, 3. Okay, so your height here is 3, and this base is 3/4, 3/4, and then this is 5/4. This distance across is 5/4, and then this height here is 5. So those are the dimensions we used. Let's look at another problem. Suppose that the integral from -1 to 6 of f of x dx is equal to 5, and the integral from -1 to 6 of g of x dx equals 1, and the integral from 1 to 6 of f of x dx is equal to 8. Determine the following definite integrals. A, the integral -1 to 6 g of x minus f of x dx, and B, the integral from -1 to 1 of f of x dx. Let's look at a solution for part A. For the integral of from -1 to 6 of g of x minus f of x dx, we want to invoke the subtraction property. So if you have the integral -1 to 6 of g of x minus the integral to minus f of x dx, we can rewrite that as the integral from -1 to 6 of g of x dx minus the integral from -1 to 6 of f of x dx. And then we can look for the numbers that we had. The integral from -1 to 6 of g of x dx, that was equal to 5, and the integral from -1 to 6 of f of x dx was equal to 1. So then we have 5 minus 1 equals 4. So 4 is the answer that we get when we do the integral, or when we solve integral from 1 to 6 of g of x minus f of x dx. Integral from -1 to 1. And when we have numbers here, that's why we call them definite integrals, when we have numbers on the end. If we never had numbers, we would call them indefinite integrals. So the definite integral from -1 to 1 of f of x dx, we make this look like an x, and we can make a lambda right here, so make it look like an x. Now, we don't have this specifically in our work, right? In our given work. So now we have to kind of improvise, okay? We have the integral from -1 to 6, and we have the integral from 1 to 6. But we want to find the integral from -1 to 1. That is like these two lower bounds. Now, if you drew a diagram from -1 to 6 and 1 to 6, you note then that the difference would be the distance from -1 to 1. So here we can apply our subtraction property. We can apply our subtraction property, so we take the area from -1 to 6 from the area from the area from 1 to 6. Take that from the area from -1 to 6. So then we're doing the integral -1 to 6 of f of x dx minus the integral from 1 to 6 of f of x dx. Same f of x dx. Okay. And so that would be equal to 5 minus 8. 5 minus 8, that would be equal to -3. So -3 is a solution for the integral of -1 to 1 f of x dx. Thank you very much for watching. Like and subscribe, and see you next lesson.